Okay, so welcome to part 5 of the first segment of network attack and defense. This part we'll start with looking at some more features of Wi-Fi. So Wi-Fi is the popular name for IEEE 802.11. That's the official name of the protocol. And in this protocol, 802.11 protocol, there's idea of a service set, which is almost always a local set of devices on a Wi-Fi local area network that are all of these devices are in infrastructure mode, and there are multiple modes that you can have in wireless protocols. A service set is usually identified using a 32-byte service set ID or SSID, and you will see these abbreviations quite a bit. An access point will have a MAC address. A MAC, if you remember from last time, the time before, is media access control, and so every networking device will have a MAC address or hardware-based MAC address burned into the chip that does the media access, for example, Ethernet or Wi-Fi, things like that. That access point is the top level controller for a set of associated stations. So stations are local area network stations, would be like your computer or a smartphone, things like that. And so you have an associated set of stations in a basic service set, which is identified by the MAC address, but it's also called the BSS ID, the basic service set ID. And that's the 6-byte MAC address of that wireless access point. You can also create extended service sets. So these are 2 or more basic service sets that use the same SSID, service set identifier. So for example, if you walk into the UWRF, University of Wisconsin-River Falls campus, you will be using the SSID EduRoam, which is actually a international SSID. And so if you're on the UWRF campus, as long as you're authenticated to EduRoam, you can access the EduRoam network, because all of these campuses sort of recognize that protocol. So that's an extended service set. You can also create other service sets like the mesh BSS S's and independent BSS S's. So typically what happens is if you have a laptop or a tablet or a smartphone and you go into something like a cafe, you have the client station, and that client station will broadcast a probe request. And so this is part of the IEEE 802.11 protocol. You send out a probe request basically asking, is there an access point in this area? And so the area is however far your device can transmit. If there is one, let's say you walk into a cafe, the cafe access point will send back a probe response with its SSID. This client, so that's your smartphone or laptop, will send an authentication request to the SSID sent in clear text. The access point will then acknowledge this authentication request, and then the client will send an association request with speeds. It's basically negotiating to see how fast, what kind of protocol you can use. And so remember, these access points are capable of many kind of speeds and protocols, whereas your device might only be able to handle some of those. And so the client will say, this is what I can handle as far as speeds, and then the access point will send a response saying, okay, go ahead on this channel with this speed, and so on. You also have things like on an Ethernet network, you might have things like address resolution protocol, which maps layer 3 IP addresses to a MAC address, which is, remember, layer 2. So IP is Internet Protocol, that's at layer 3. MAC is media access control, that's layer 2. That's, remember, the 6-byte address burned into your NIC. The thing about this protocol, it's just like with the probe request and the probe response, there is really no authentication, and it can be spoofed. Although in Wi-Fi you actually do authenticate with the SSID, you don't know if this SSID is actually what they claim to be. Okay, so somebody can spoof the SSID. So in a lot of these situations, the problem is that if there is authentication, it's sometimes only one way. That is, you might authenticate with the access point, but not the other way around. And so if there's ever a situation like that, then these things can be spoofed. There's also inverse ARP, that is a way to obtain IP addresses of other nodes based on their MAC addresses. So if you find MAC addresses by, for example, accessing the switch or something like that, then you can find their IP addresses. There's not much call for using that anymore these days, and you can also do reverse ARP, that is obtain the IP address of a requester using its MAC address. However, this is not used much either because it's replaced by the BootP and DHCP packets. In IPv6, ARP is completely replaced using what's called the neighbor discovery protocol. So a lot of these things sort of just go away, and some of these security vulnerabilities go away with IPv6. So one way of simplifying configuration is to use what's called DHCP, or Dynamic Host Configuration Protocol. DHCP allocates IP addresses to different nodes on a network, and you need a DHCP server. So if you're on a local area network and your machine just starts up, what it'll do is check your network settings, and then it might, for example, be set up by default to contact a DHCP server. And if that's the case, it will broadcast a DHCP discover request. The server will get this request because it's a broadcast, the server on that local area network, and then checks if the MAC address that or checks your MAC address, and if it did lease an IP address to your MAC address, it just renews it and says go ahead and keep using the same IP address. Or else, if it's been long enough that someone else maybe got that IP address, or you just haven't used it for a while, you might get a new MAC address in a DHCP offer packet. The goal of DHCP is to ensure that each IP address is unique. So on any network, there's only one machine with one particular IP address. You should not be able to have two machines with the same IP address on that local area network. There's no authentication in this case, but there are ways to restrict this process to hand out IP addresses, maybe to only known MAC addresses. So to do this, you have to know the MAC addresses of all the machines that are potentially going to connect to that network in the future. So you can restrict the DHCP to only hand out IP addresses to sort of devices that you know about. Spoofing can also happen in GPS. So for example, in 2011, an American CIA drone, the RQ-170 military drone over Iran, was commandeered by the Iranian military by feeding it fake GPS signals. So this drone was flying around, and the Iranian military figured out that it could feed it GPS signals that were stronger than the ones it was getting from actual satellites and things, and then you could redirect that drone to go wherever you want it to go. So these kinds of attacks on local networks, like spoofing Wi-Fi access points, spoofing ARP responses, GPS signals, these kinds of attacks are attacks on authenticity. So you're pretending to be someone that you're not. You're impersonating some existing host. There are also other attacks like packet sniffing that we have used using Wireshark. So Wireshark is actually using packet sniffing. It is sort of an attack in that you could potentially violate confidentiality, and that's the reason why you don't want to use things like Wireshark on an actual network, only on virtual machines for lab. Goal of the attacker in this case would be to get information, things like usernames, passwords, and credit card numbers, things like that. Another attack is man-in-the-middle type attacks. There, what you're doing is violating authenticity. We also did this in the lab. The idea is you want to impersonate a target. A denial of service attack, on the other hand, targets availability. That is, you're trying to shut down a server or something. So the goal of the attacker is to reduce availability of some server by disrupting normal operations. And one reason for this might be to extort either money or some kind of favors or something from the target. So packet sniffing software like Wireshark can grab network packets on an Ethernet or Wi-Fi connection, and the goal is to get usernames, passwords, credit card numbers, things like that. Most organizations have rules banning packet sniffing on their networks, so you basically just should not do it. These days you can be prosecuted by law enforcement for doing something just like running Wireshark on a computer. However, these days also there's another countermeasure, that is encryption. And so you might be able to get packets, but the data is all encrypted. And so this is encrypted in essentially like in layer 2. And so a lot of even the metadata about what IP addresses it's going to might be hidden by encryption. Facebook really only started using encrypted web traffic, that is HTTPS, in 2011 as an option, and then became default by 2013. Before that, there were actually tools that you could buy to get network traffic that is going to Facebook and see people's usernames, passwords, and things like that. And organizations like NSA probably do the same kind of thing on a massive scale, that is harvest information and get the metadata, that is the source and destination of where these packets are going, and figure out who's talking to whom, things like that. MAC spoofing is a way of using fake MAC addresses or MAC addresses of computers that don't belong to you. So remember, MAC address is media access control address, and so each network interface has a MAC address that is hard-coded by the manufacturer. It's a unique number used on local area networks to identify each computer. Thing is, these MAC addresses are not always authenticated. The networking part of an operating system can actually change the MAC address that it advertises to local networks, and that's called MAC address spoofing. So far, this is not really considered illegal. It's used by, as we saw earlier, companies like Apple to prevent your devices from being tracked, to mask your identity. And in virtualization, when you spin up a virtual machine, you actually just generate fake MAC addresses. The idea is that these are 48-bit addresses, and it's very unlikely that you would have another machine that has the same exact MAC address, maybe a real machine with a real MAC address. Chances of any particular VM having the same spoofed MAC address as a physical machine is 1 in 2 to the power of 48, which is pretty small odds. It can also be used for evil purposes, like an attacker can use the MAC address of a target and then get an IP address from the DHCP server, things like that, and monitor traffic, things like that. That would be bad. You can do SSID spoofing, which is similar to MAC address spoofing, and so the idea there is that an attacker can set up a rogue wireless access point with a fake SSID and can take advantage of clients that send probe requests for Wi-Fi connections from the past. So for example, if your home Wi-Fi access point SSID is on your device, stored on your device as one of your preferred networks, and you come into a cafe and you ask, is my home address here? This rogue access point can detect that probe request and say, sure, I'm your home access point, and allow your smartphone or your device to join, And to your smartphone, if you're not careful, it will look like it's joining your home network even though you're not anywhere near your home access point. And this is the basis of what's called the karma attack. You can buy $100 device, this was years ago, that you can called Wi-Fi Pineapple. It would run this code host apd.1.0 slash hyphen karma, and it would do exactly this. You can walk into a cafe, and with this it's a very small device, you can start pretending to be everybody's preferred access point, and then your system, the people in the cafe will try to connect to your device thinking it's their access point, and then maybe end up, if you forward their traffic to the actual site, let's say the cafe access point, you can monitor all of the traffic going between all of the people in that cafe and all the places that they want to visit. There are also things like Airbase NG. It's a software package that will allow you to crack wireless password, wireless encryption keys, things like that. And these are actually, this is available in Kali, in the Kali virtual machine that we're using in the labs. ARP spoofing is a way to pretend to be someone that you're not on a local area network. So remember, ARP, address resolution protocol, maps an IP address to a MAC address on a local network. And so what you're doing there is some machine knows the IP address of another machine they want to talk to, but not the MAC address which they need to send packets or frames on a local area network. And so if you want to pretend to be someone else, you can use ARP spoofing. Essentially what it does is poison the ARP cache that's held locally, or is also called poison routing. So an attacker is able to route traffic on a local area network and to itself instead of the actual destination. So this is used to intercept or modify data frames, stop traffic, launch a man-in-the-middle attack or denial of service attack, and can do session hijacking of even web connections to the outside. So under normal conditions, a LAN user is maybe connected to a switch through a gateway to the internet, and let's say this LAN user is talking to their bank way out in the internet. You can have a malicious user pretend to be this LAN, say, client, and thereby get all the traffic that's intended for this LAN user to go to the malicious user. Okay, so a malicious user can give the wrong answers to ARP requests and claim to be the target of the LAN user and send a fake subnet mask and all of that, and thereby pretend to be the LAN user, thereby figuring out what addresses or what places this LAN user is accessing on the network, for example, your bank website, things like that. IP masquerading or IP spoofing is another thing you can do. This is actually used with NAT, so it's not exactly an evil thing to do. So the idea in a local area network is that in the outside world, everything inside a network will be given one IP address, for in this case 203.10.23.1. Inside the net, this is the outside view, and this might be an address given to you by your internet service provider. And inside your home or your office or whatever, you have private IP addresses like 192.168.1. something. The default gateway or the router is usually 192.168.1.1. that's the one at the very end, whereas each of the workstations or phones or laptops will have 192.168.1. and then various other numbers like 2, 3, and so on. And so when these two machines, for example, can access the same site on the outside, and it'll appear there that even though they're two separate machines, to the outside connections, it will look like both of these machines have the same IP address, 203.10.23.1 or whatever. Okay, so the original request from, let's say, one of these machines like this one, it's coming from 192.168.1.3. It's going out, let's say, on a particular port, and it goes through this masquerade router or NAT, and all of these requests are transformed into these IP addresses and these ports. And so let's say you're going to your bank site, and then if you get a reply from the bank, it'll go to this same IP address, maybe a different port or the same port, and the network address translation table in here will convert that to a different IP address and a different port potentially. One reason for using NATs is to hide these internal networks for security, and also it also bypasses that IPv4 32-bit address exhaustion. So there's a ton of networks that use private IP addresses, and that's basically sort of makes network or IP address exhaustion no longer a problem. So you can have evil ways of masquerading your IP address, and one reason for doing that might be to pretend to be someone you're not. That is, you set your IP address to be that of a target that you want to pretend to be. Why would you want to do this? To do things like monitor target activity, or launch a man-in-the-middle attack and hijack sessions, web sessions, things like that. So for example, target may have a firewall that filters out traffic to its IP address that is not a response to its own packets, and if that happens, no alarm is raised. Okay, so that concludes the segment 1. This is end of part 5, and in the next segment of network attack and defenses, we'll look a lot more at vulnerabilities. Hopefully you got a review of basic networking in these 5 videos.